everyone. I've been getting a lot of questions about transformations and residual plots and just, kind of the whole thing here. One of the things that I want you to understand, when you get a set of data, you are going to, first, you're going to plot it because you need to look at the scatter plot and you need to determine if that data is straight enough. So the first question you're asking yourself is it straight enough? Okay. The reason why you're asking yourself this is because you can always do a linear regression, but maybe you shouldn't do one. And so just because you have the technology and you can tell your calculator do linear regression doesn't mean you should. So the first question you ask yourself, you look at the scatter plot and you then say, is it straight enough? If it is, then you are going to run a linear regression. We know that in AP Stats, we use A plus BX. This is the same as mx plus b in algebra, where b is your slope and a is your y-intercept. They're switched. I don't have a good reason. It's just the stats way. You are using this as a prediction line, so you have to use y hat. And one thing I'd like to remind you as well is that if you do a linear regression line, if you're asked to come up with a linear regression line, you must identify your y and your x variables. So even if it doesn't say define them, you have to do that or you won't get full credit. Now, this is kind of step one. Once you've done this, you now have a line of best fit, right? We call that in algebra. And your next step then is to look at the residual plot. If you look at the residual plot and you actually see a pattern, so here's a pattern where I've got this U-shaped graph. This looked really good to my eyes, but actually I see this pattern here. Pattern is no good. Pattern, no good. So what we're then going to do is start looking at transformations. Now, one thing I don't want you to stress out over with the transformations is that you are not going to have the time on the AP exam to have to figure out, okay, what transformation do I need to do? They're going to do kind of all of it for you, kind of like you've seen in the problems so far, where they're going to give you a couple of different choices of transformations, and you have to pick the best one based on the residual plot, based on the scatter plot, based on the equation of the transformation. So, for instance, you may get a residual plot that shows this, and you're going to, without even knowing anything about the problem, you're going to say, okay, this model is not a good fit. But maybe the model that's not a good fit is this. Okay, they've given you a square root. This is telling you that it wasn't linear to begin with, and it's not very good. Maybe the next one is scattered about, right? This looks good. This residual plot looks good. But this one is the log of y hat equal a plus bx. Again, this is nonlinear because linear is a plus bx. So if there's anything done to the y or to the x, it's not linear. Again, maybe you have a residual plot that looks like this, and you had y hat equal a plus b, maybe x squared. So they're going to give you these equations. Now, one thing I've got to tell you is that when you pick the best one of the things you're going to have to do is use it for prediction, and you're going to have to solve it for y. So in this case, if these are all residual plots, this is the best one because there's no pattern. No pattern is good. And so this is my best choice. When you go to, and this is something that I put a little reminder on the top of the screen because of that. When you were in either Algebra 2 or Pre-Cal, you should have learned logarithms. You should have learned that you can rewrite them as b to the x equal y. So logarithms are just a different way to write exponents. For instance, if I had log base 3 of 9 equals 2, if I were to rewrite that, that would say 3 squared equal 9. And that's a true statement. So this is something that you have to remember, or you might have to relearn. If I don't have a base here, it's base 10, so that would be 10 to the x equal y. So that is literally just memorizing how to rewrite something. Now, with this equation, the log of y hat equal a plus bx, if I'm then asked to make a prediction with it, which I often am, I'm going to need to rewrite this as 10 to the a plus bx equal y hat. I need to solve it for y hat. And you had one with these, I know you have some numbers in here. This is going to be 10 to the a times 10 to the bx. And what you're going to do and what you did in your, I think it was in 2.03, maybe 2.04, you're going to actually calculate what these 10 to the a and 10 to the b are. And if you remember why this is multiplied, remember when you multiply, you add your exponents. So I'm just kind of breaking it up, working backwards. So if I had the log, I'm just going to make something up here, of 2.3 plus 4x, that would be 10 to the 2.3 plus 4x equal y hat, or 10 to the 2.3 times 10 to the 4x. And I would literally do 10 to the 2.3, the calculator here, the batteries are low on it, 10 to the 2.3, which is 199.526. And I would do 10 to the fourth. I'm just going to do 10 to the fourth, which is 10,000. Remember, I made this up. And then to the x power. This would be solved for y hat, and I can now use it for prediction. I could just plug in whatever my x value is for prediction. We did that. I think there's a couple examples with logarithm in there. If for some reason this was your best choice, and you had the square root of y hat equal a plus bx, to get rid of square root, you simply square it. So you could just say y hat equals a plus bx squared. You do not need to FOIL that or do anything like that. But again, you could plug in your x value to make your prediction. So as you're doing these transformations, you will have to solve them for y hat if they are not already solved. Please contact me if you have other questions and let me know if I can help. Have a great day.